Good morning, good afternoon, good evening. I see lots of folks joining us this morning. Thanks for hanging with us. It's a good week to start. Lots of interesting technical sessions for the PI 15 Mojaloop convening. Thank you so much for joining. I see lots of familiar names in the attendees list. Just give everybody else a couple of seconds to join, and then we'll formally kick it off. Excellent. So good morning, good evening, good afternoon, everybody from wherever you are. Welcome to our convening. Very exciting week. I have a few housekeeping items before we begin. So we'll share my screen just to guide you through this. Most of you by now are familiar with our convening program and the agenda. This is how you got in here. So just a quick reminder that you will need to come to these cards and session after session, click through on the cards. For example, we're in the reference architecture version 1 session, which will bring you to a page like this. And in this page, this is where you'll be able to join the meeting. You'll need to do that for every single session. So a quick reminder to do so. In this page as well, you will have the chat. I see lots of people saying hello. Louis, Sam, Kadidia, thank you all for joining and for using the chat. You'll also find links to any polls that need to be happened during the sessions. The slide presentations will be uploaded to files if the teams make them available. And you can see who else is registered for the session and who you can chat with and reach out. So thank you all for joining. I will welcome Paula to give her intro remarks, and then we'll kick it off with Adrian. We'll pass it over to Adrian to kick off the reference architecture team. So Paula.
Thanks, Simeon, and no worries, Adrian. I'll be brief. I don't want to cut into your time too much. So just looking back in January when we had our, I don't know if it was our fourth virtual convening, we talked about our focus for this year, and our focus is on gaining traction and seeking new deployments. And I'm hoping that you'll hear some new updates tomorrow morning about what we're doing in Rwanda. And we also have several other projects in the pipeline. So I want to thank all of you that have assisted us in moving things forward and gaining traction in key countries so that we see ourselves achieving that goal of having some new deployments this year. But of course, we can't do that without you and all the hard work that you do during these program increments. So I thank you for that. Moving forward, we don't want to forget the business folks. You know, we shifted these sessions to entirely technical in the interest of saving you the fatigue of a full week session. But we haven't forgot the business folks. We had a PISP webinar last month. It was greatly attended, got a lot of great feedback on that. We're planning another webinar in the fall, but we're also planning a business focused event, a 3-day event in September, where we'll have a number of topics that are related to deployments and why Mojaloop and how to sell and position Mojaloop versus other offerings in the marketplace. So hopefully, if you're interested, we'd encourage you to participate, but also to encourage your business colleagues in your companies to join as well. So you'll hear more about that in the upcoming weeks, but we wanted to really stay focused right now on the community event. And of course, we do have another community event scheduled in October. Sadly, it will be virtual once again. I'm sorry I won't be able to see you all live, but let's hope 2022 brings a new promise of travel and most importantly, getting to see each other face to face. One last other item, tomorrow afternoon during our open discussion, the Modusbox team has some exciting news to share about their payment manager tool. Warren Carew is going to provide an introduction at 4 p.m. UTC, and then we'll open a breakout room for deeper discussion. So I encourage you to stay on tomorrow afternoon. I think you'll be really pleased with the news that Warren's going to share. So with that, I wish you all a great week. I see that the chat's lively, so I'll be monitoring it as well. And at this point, I'd like to turn it over to Adrian to kick off the opening session. Over to you, Adrian.
Thanks so much, Paula, and welcome everyone, and thanks for your time. Before we kick off, I just want to say a big thanks and huge congrats to everyone who was involved in putting this reference architecture together over the last PI. It's been a lot of work, and especially to Pedro, who's been herding the cats and coordinating. So the plan for this session is we'll recap a little bit about why we're doing this, what a reference architecture is, go over some more detailed flows of what this next iteration of the platform looks like, and then finally and most importantly, we're looking for resource commitment on the build. So we have a build plan, a high-level build plan, and we want people in the community to commit resources to helping us make that a reality. So that's all I'm going to say on the reference architecture. Again, want to emphasize a big thanks to everyone who put in all the work to make this happen, and hand over to Pedro to take it from here.
Thanks, Adrian. Well, welcome everyone, and hi everyone. So to start this presentation, I'll quickly go over some of the fundamentals. Most of it, or at least some of it, you've heard last PI, but this is a bit of a refresher, which is essential to set the scene. And we'll start with what is a reference architecture and why we need one. So a reference architecture, in the most simple form, it's a set of documents that capture the essence of the product and provide guidance to the implementation of future versions. And this is an iterative process. It doesn't end with these deliverables. This is constantly being updated as we progress. It identifies abstractions, interfaces, and standardization opportunities. It proposes solution patterns to common problems. It helps enforcing technical design principles, but it also provides guidance to the actual implementation architecture. So every time that we have feedback that comes from this more theoretical exercise that can be fed into the current implementation, we will take that opportunity. Lastly, it fosters innovation and contribution by defining what can be done and how can it be done, and hopefully we will be able to contribute much in a very easy form with this new version of the platform. We followed some general principles, such as we need the right level of abstraction. So a reference architecture must be detailed enough to have some value, but not too detailed to limit the actual implementation. So this is not a recipe on how to implement every little detail, but we need this right level of abstraction. And we have agreed during this exercise that right level of abstraction is the bounded context. And this is some term that we borrowed from domain-driven design that we explained in the previous presentation during the previous convening. And these will be the yellow boxes that will be shown in a few slides forward. This has also in consideration the single responsibility principle and decoupling the core subsystems, such as the most important thing of the design is to identify the interfaces between those subsystems, making sure that each part of the system does one set of functionality really well and doesn't step into the other parts of the system. By having these well-defined and stable interfaces, we are achieving that very important decoupling that enables us to evolve the parts independently and even replace some of the parts if we need by just respecting the interfaces that are supposed to be stable. As per our original design principles, the communication between the parts of the platform should be mainly asynchronous and event-driven. But we also have agreed that some communication paths, which are maybe less critical or don't require a high degree of parallelism and performance at scale, maybe we can implement those in a simpler RPC form. Of course, the reference architecture must also propose mechanisms to ensure that the platform is secure, performant at scale, cost-effective, modular and extensible, resilient, testable, easy to deploy and operate, All of these things are pretty obvious, but we know how easy it is to negatively affect one or more of these with the technical wrong turn or technical wrong decision. And these properties, these abilities are always in our minds when we're designing and building the next generation. Sorry. So those parts are very technical. In practical terms, what we want to be able to deliver is we want to be able to avoid dependencies on any single specific infrastructure component. And we address this by having those abstractions for all infrastructure access, decoupling infrastructure components from the valuable code that executes our features, so that we can change implementation with minimum effort. Think about, in the most extreme example, replacing Kafka with any other equivalent infrastructure component. That should be possible. Even if it's not desirable, we need to design for those scenarios. We would like to extend the platform by adding more features without having the need to change the core components or even access their data directly. And because of the stable interfaces and the data hiding principle, it should also be possible to completely replace a core component. And in the future, we will see examples like this with Tiger Beetle. This design allows us to provide multiple external APIs. And besides FSP IOP, we can also add ISO 222, or even an additional synchronous API without the change of the core platform. This is an important aspect because the core of it is too critical and too important to be changed whenever we change the outside or eventually the infrastructure. Ultimately, we would like to provide the foundation for a true marketplace where anyone in the community can contribute by adding new functionalities, new features, or even replacing those components that already exist. And this should be easy to accomplish. One should be allowed or enabled to replace a part of the system or to extend the system with new plugins and new features in an easy fashion without having to understand the full system. So as we mentioned previously, we resorted to domain-driven design and some of its advice for the work plan. We started by getting a solid understanding of the problems that we were solving. So we put everything on a screen saying, this is the problems that we have to solve. This is the functionality that we have to deliver. And then we map those against, according to its relative importance. And this is really difficult to do. We actually spent some time, and there was a lot of people involved because mostly we think we agree on everything before starting the conversations. And as we start mapping the problems that need to be solved, we quickly realize that we don't have an agreement about how things should be solved. We then arrange those problems in cohesive sets of solutions where related problems are solved together. And these arrangements, this is the basis for the future solution. Only then we started working on the actual reference architecture and the future version design. This is the result of a lot of work. This was distilled from very complex diagrams that we had because they wouldn't be readable at all on the screen. So this apparently simple diagram, and I say simple without irony because this is much simpler than the rest of the stuff that we have. This is our context map, where each of these yellow boxes is a bounded context solving related problems together. You can see at the bottom layer of the external APIs, this is the orange boxes. Themselves are also bounded context. And these are sets of components that are responsible for the interaction with the outside world, be that FSPs, operators, or any other party. And they will forward every request to the correct bounded context for proper handling. In the case, for example, of FSP interop APIs, they will translate FSP IOP or the future ISO implementation into the canonical messages that the yellow boxes inside understand. And this is an important concept that we have because we are now having a sort of canonical mechanism internal to Mojaloop, which might sound extra work, but it actually allows us to, in the future, have multiple interop APIs or mechanisms to interact with the switch if we need to. Some of the problems that we have to address are of a general nature. Essentially, those are what we're calling cross-cutting concerns, and they don't belong in any specific of those yellow boxes, the bounded context. But they have to be delivered. They have to be designed and implemented in a consistent way by the entire system to deliver value and to make sure that we have a sound platform. Last PI, we didn't have time to dedicate it to these areas, but during the last couple of months, we detailed and designed solutions for all cross-cutting concerns, and we now have a very clear idea of how to implement those for the next version of the platform. Most of these have a distributed model, with some part of the solution being handled centrally for consistency and abstraction, and other parts being handled in each bounded context for flexibility and ease of development. We will have some examples of that in the next few slides. And now we're going to the section where we are going to show you the details of how the flows work in the new design that we have thought for the future version of the platform. And with that, I hand it to Johan now.
Good day, everybody. Very glad to be here, and thank you for having me as part of the Mojaloop team. And what we're going to be looking at firstly is the this is how it works series, is the participant onboarding, or what we would like to call in the future as the single step sign-on, which is simplifying the participant lifecycle onboarding process as we know it currently. And what we also going to incorporating with the single step, making it more simple, is also making it slightly more complicated by adding maker checker procedures to ensure that all the data that gets either written or manipulated in a form always has these 6i verification, so that a single person cannot be responsible for malicious activity if it were the case, either being intentional or through negligence or coincidence. And so when a maker, which is now the creator of this participant, would be onboarding this participant onto the Mojaloop ecosystem, it would use the operational or previously known admin API to interact with the participant lifecycle management toolset, or bounded context, excuse me. And within the participant lifecycle management, we would do all the calculations to verify validate the request, validate the semantics around it, doing duplicate checks, and evaluating scheme rules to determine whether this maker is actually allowed to do it, and all of these checks naturally take place in the participant lifecycle. And then after all of these checks have passed successfully, we put that participant that's now in a created state and in an intermediate pending approval state. We notify the checker that there's a new item in the queue, and they can refresh whatever interface they're working with to retrieve these participants. Then that is now on the left-hand side. Now, if we move to the right-hand side, we come into the domain of the checker, the person that has to authorize the participant to be created. And when we in the initial step, we have to first see what participants we could approve. We have to find all of these participants in a given state and say, okay, participant lifecycle, please provide me with all of these pending approvals. And then there will be an approval or rejection. Showing here is the success scenario of acceptance. And what happens after the participant lifecycle also does a bit of validation and creates the data within its own system. It sends a request to the accounts and balances bounded context to create the accounts and limits. And then it also sends out a notification to the settlement bounded context that notifying that a participant has been created. And I believe Michael Richards will expand on that slightly later down the line. And then we send back a notification to that maker to notify them, listen, your participant that you would like to create is actually successfully created. And yeah, that's the single sign-on, well, single step sign-on for participant in a nutshell, basically. And yeah, I'm going to hand over to Miguel for the transfers, bounded context overview, and yeah, that's everything from my side.
Thank you. Thank you, Niall. Thanks, everyone. Right, so I'm going to take you guys a bit through the transfers and how that looks, but I thought it would be a good idea just to cover or quickly cover an overview of the bounded contexts that are part of the transfers use cases that we have. And I'll be taking you specifically through a happy path for prepare and a fulfillment, just so you can get an idea of the interactions of these bounded contexts. So let me put my arrow on. I think you can see my arrow here. So I'm just going to be pointing at stuff on the screen so I can refer to that. So for example, the main one that we're dealing with really in this context is the transfers itself. This bounded context is obviously going to process the transfers. It's going to handle things like duplicate checks, crypto conditions, and it's going to handle the state management of the transfer itself and potentially handle compensating actions if a transfer was to time out, etc. The next below that, we have an FSB interop API, and this is an interop adapter, right? So this adapter specifically implements the Mojaloop FSB API specification, and it also handles any compensating actions from that perspective as well. But more importantly, this is also referring back to what Pedro said, that if we wanted to support ISO, etc., this component here could be interchanged for that ISO adapter. We also have the participant lifecycle management. I think Noel's also covered a lot of that. This pretty much is the participant lifecycle management, handling the onboarding, any kind of participant data itself. On the right, we have the accounts and balances, and this is the system of record for hub and participant financial activities and balances and liquidity checks, the position check, etc. In the middle, below the participants, we have settlements, and Michael will be going through that in more detail. But this is more or less where, or the important thing for transfers is this is where the settlement models are managed, and also where the actual settlements are going to be processed. On the right of that, we have a scheduling bounded context, and this is really its own bounded context where we can basically, through APIs, schedule time-based events or alerts, and that scheduling bounded context can then trigger alerts back to another bounded context and say, hey, your scheduled timeout has occurred. And this is great for transfers because when a transfer is received, we will then call that. We have notifications itself. So this is a reliable notification component with retry mechanisms and a persistent state to handle failure modes. But more importantly, it handles also the notification delivery reporting mechanisms as well. And that enables us to do SLAs and compensating actions further on. Can we go to the next slide, please? So this is a transfer, right? So just a couple of things I'd like to point out here. You'll see some solid lines here. So these are basically RPC or REST API calls, and we expect a synchronous response to come back in this case. And we also have these dotted lines, and these are events, right? So in many of the cases, we have these two modes of communication between our bounded contexts. And you'll see it's a mix of them depending on the use case and how we choose to apply these communication patterns. But on the far left, you will see the payer FSB. So this is the usual Mojaloop post-transfers request that comes to the FSB interop API. And that will then do a couple of things, specifically validating the request structure, validating the semantics of the request from an FSB interop API specification perspective. And that will then basically produce an event called the transfer prepare requested. And at that point, it would then respond with the 202 accepted, which is not shown here. I've tried to keep this as simple as possible. If you go to the Miro board where we've documented these in more detail, you'll be able to see those individual actual callback responses as well. So here we have this event, transfer prepare requested. It's going to be consumed by the settlement management the settlement bounded context. And the reason for this is we need to also find out what accounts need to be basically updated. So what ledger entries need to be updated based on the transfer itself. So the settlement component here is basically going to select the accounts for the participants, and it's going to enrich the message over here, this transfer prepare accounts allocated. So we have the original prepare request plus the accounts that need to be included for any kind of changes to them based on the transfer itself. That will then be received by the transfer bounded context, and it will do some validation checks, such as check for duplicates, and it will also go and fetch information about the participants to also make sure that they are valid. Can we transact with these participants themselves? And of course, this is where the state management happens for a transfer. So we'll also persist the state as well as that account information that we saw earlier. It will also then send a API request to the scheduling bounded context to also then create that schedule reminder for the timeout for this particular transfer. It will then also then do a API call to the accounts and balances, where we want to basically debit the payer from a liquidity perspective and credit from a reserve perspective. And that will then obviously add the ledger entries to the accounts and balances, and it will also be where the position check occurs. Of course, that will then respond over here, and we will then receive a response that includes the change of the balances for those accounts. Or we would also at that point receive some kind of response indicating if the position check failed, for example. That will then result in a transfer prepared event being produced, which will be consumed back by the FSP interrupt API. And at this point, the FSP interrupt API has seen that the transfer was successful, and it will basically now set itself up to send the request to the payee. And to do that, it's going to send a notification. So it first must go call the participant lifecycle management to fetch the participant callback URIs, and it will then construct a notification request and then send that to the notification bounded context, which will then send that out on the FSP interrupt API's behalf to the payee. The notifications bounded context will then obviously handle the notification delivery report, which will be received back by the FSP interrupt API, and that will result in another event called the transfer prepare callback report, where the transfer will be updated to say that the prepare was the prepare notification was delivered or was sent to the payee, and there'll be also a state change to reflect that. So then moving on to the fulfillment, we have then the payee, which responds with a put transfer. Similar to before, we have that usual validation of the structure of the request and the semantics of it, and that will result in the transfer fulfill committed requested event being produced. The transfer will then receive that. It will then validate that transfer and make sure, hey, did I receive the, did I receive the prepare, and was the prepare successful? Yes, it was. We can now do the fulfillment, and it will also do the cryptographic condition check here and compare the fulfillment and the condition parameters of the Mojaloop API specification here, and make sure those are valid. And if they are, we will do the final debiting and crediting of the payer and the payee on the accounts and balances. And we will then produce a transfer committed fulfilled event. And you'll see here, it actually branches off to more than just the interrupt API bounded context, but it also goes to the settlements, and it also goes to the participant lifecycle management. So from an FSP perspective, we obviously want to send out the final fulfill notification to the payer, which we follow the same pattern, fetch the callback URIs, send it to notification. And once again, we get the notification report where we update the transfer into its final state. But also for settlements also needs to be aware of that transfer being in a final committed state. So the actual process can happen from a settlement perspective, which will then Michael will cover later on. And also from a participant lifecycle management, we also maybe want to manage the processing threshold notifications. So there might be additional notifications that need to be handled that are configured within the participant lifecycle, such as a participant can only send so much or can only do so many transfers in a day or maybe a week. And those kind of thresholds will be handled by the participant lifecycle management itself. And that can end up being that could end up resulting in a new notification being sent out, or some other kind of compensating action, depending on if those thresholds are passed. It's also things like whether we reach 80% of our net debit caps as well, our position checks as well. This is also the point of where those notifications would be scheduled as a result of these threshold checks. I think that's it from me. I think moving on, Pedro, to settlements. I think it's Michael.
It is indeed. Thank you very much, Miguel, and thank you for explaining the overall context of the design so ably. So I'm going to talk in a much more restricted way about what we're planning to happen in settlements. And the first thing I want to do is to say, this is not settlements as we have it at the moment. It's a new version of settlements, which we've been talking about for some time with participants. But basically, the characteristics of that are, first of all, it works from batches, not windows. At the moment, we just have a single settlement window and all transfers that are completed go into that. The plan is now that we will have batches. There will be multiple settlement batches. Thank you, Pedro. And that we will deterministically assign transfers to settlement batches. Now, we've had a number of problems, implementers have had a number of problems because they can't always reliably tell which transfers will go into which settlement windows. We plan to change that so that people will be able to be confident that particular kinds of transfers will always be grouped together and they won't be found across multiple settlement batches, and that this will be based on configurable rules, which we expect administrators for schemes to be able to set up and indeed modify. Next slide, please. So what does the settlement bounded context do? I mean, in many ways, it's much simpler than the procedure that you've seen Miguel outline for you in the previous section. First of all, as Miguel said, it assigns completed transfers to settlement batches. So when a transfer is put on the Kafka stream, the settlements bounded context will be listening, and it will pick up that information and assign each transfer to a settlement batch. Then it reports on the content and status of settlement batches. So this is for scheme administrators, hub administrators. They will be able to look at the various settlement batches, see what's in them, see who owes what as a consequence of them, and so on and so forth. And finally, it updates the scheme's ledgers with the results of completed settlements. So when an administrator requests a settlement, and eventually reports that the settlement has been completed successfully, then it will be the responsibility of the settlements bounded context to update the ledger entries for the participants in that settlement to reflect what's happened as a consequence. And our plan is that that will work in exactly the same way for continuous gross settlement as it will for deferred net settlement. So we will have a consistent approach to all of these things. Next slide, please. So, brief connectivity map of the things we talk to. Next slide, sorry, click. First of all, as we've heard, it listens to events coming from the transfers bounded context. Next, it gets rules from the configuration bounded context. These are rules about settlement models and how to assign things. It stores information about batches in the accounts and balances bounded context. And finally, it interacts with the settlement API to produce information about what's in the various settlement batches and to implement the processes of settlements itself. Next slide. So when the settlements bounded context initiates itself, it gets rules from the configuration and stores them inside its own area. So there will be, so there will be some additional wrinkles on that, of course, because if the rules change at any point, we'll have to make sure that existing settlements bounded context get the new rules and that kind of thing. But in principle, that's the way it will work. Next, please. Thank you. Then when we add a transfer to a batch, the transfers bounded context, as we've seen, will put the transfer on a queue, and essentially that's the message that says this transfer has been committed. So next. The settlements bounded context will use rules to determine the correct batch for this transfer on. It will then ask whether this is a new batch or not, and if it is, it will create that batch as an account in the accounts and balances bounded context. It will then go on and add that transfer to the batch in the account that it just created. If it isn't a new batch, then it will just add the transfer to the existing batch. So that's a relatively simple and deterministic process, we think. So now what happens when a settlement is requested? Next, please. Thank you. It will receive, the settlement's bounded context will receive a request from the settlement API, show me these batches. It then gets that batch detail from the accounts and balances, which is storing it, and it returns that information back to the settlement API. Settlement API then sends a request to the settlement's bounded context saying, I want to settle these batches. Settlement's bounded context marks them internally as settling, but it doesn't need to do anything else at this time. Finally, it will get a message from the settlement API saying the batches are settled, and when it does that, it marks the batches internally as having been settled and sends the information on to accounts and balances so that the position, the unsettled funds and the settled funds account for that settlement model for the participants are properly updated to make sure that they reflect the consequence of the fact that the transfer is, that the settlement has successfully happened. And that is all I have to say on that topic.
Thanks, Michael. We'll now head on to a quick presentation of a couple of cross-cutting concerns, starting with platform configuration. We've designed a distributed model where a central set of services provide shared platform configuration and abstract the details of both the storage and the configuration data, as well as the actual UI and API used to change the configuration values. In our design, everything that is configurable, from small details to scheme rules, is part of the platform configuration. And these are high level, the big chunks of that strategy. So this is the bootstrapping step. A developer working on a part of a system, for example, the transfers, requires the system to have a certain configuration. In this case, transfers will require some properties to work properly, and that developer will define those, those properties into its own code. Once the new version is deployed, the transfer services will send that configuration scheme to the central configuration services. And this is what happens at bootstrapping time. From that moment on, the new configurations can be changed by a user through the UI, which is obviously going to use the API to get there. So from then on, every time the transfers services starts up, or every X minutes, or even a smarter way of doing things, upon a notification that some values changed, it will fetch the configuration values so it can perform its work with the fresher set of configurations. There's obviously a lot more detail to this that we're skipping for presentation purposes. We're keeping it simple. But this is overall how the platform configuration works. Secret management is an extension of this. It uses a similar strategy, albeit with the required security consideration. So there's a lot more there to make sure that the secrets are handled securely and are stored securely. And with that, I will hand on to Godfrey to explain us how security works in this new platform.
Thanks, Pedro. So yeah, I think the theme around how we've built the common services is more around abstraction as much as possible, so that we don't hard code things into the various aspects of the application. And this actually helps us to achieve much more, agility, especially in view of implementing, various security policies and various compliance requirements. So in terms of organization, in this domain, we actually have, this domain that we actually deem as security-specific domain, and they're addressing, key concerns of, confidentiality, integrity, as well as availability across the board. And starting from the first one, we have a kind of like, an auditing bounded context, which we actually use it as a central way of getting audits from all the other bounded contexts that are in the architecture, and send all the audits to a central place, wherein they will be able to be managed with a consistent policy. in terms of whoever needs to access those audits could be actually be controlled, and also to satisfy some of the compliance requirements from a forensic perspective. We will actually guarantee immutability by integrating this with our crypto, BC, to make sure that all the necessary messages are signed and where needed is actually encrypted. And the login BC as well will actually follow the same kind of like flows and concept as the auditing, but with exceptions that logging will actually take any event that happens on a BC and store it in here. And signing those events is actually kind of like optional at all. And moving over to the authentication, BC, the years wherein we handle issues of, user authentication and identities, and we actually keep it as much more simple as we can to make sure that this is universal and this can actually be federated across, the entire, landscape, wherein we keep, the usernames and the repositories outside the system, and we can actually connect to external repositories to do, the identity checking, the identity verification. And for this specifically, we will actually be building an abstraction layer which connects to external systems, so that each implementer will have the choice of their own external system. And also with regards to authorization, we'll actually be embedding this deep to actually enforce least privilege access across all the BCs, wherein BC to BC communication will have to be authorized based on a set of roles and privileges that will be associated to BC. And moving to the crypto side is really a common function that will actually facilitate across all the other security BCs, and providing a secure abstraction for all the cryptographic functions that will be able to do them on the subsystem that actually satisfy the regulations. Where people need to actually store this in a HSM type environment, the abstraction layer from the crypto BC will actually play that part and hide all the complexities behind it. So this is in a nutshell all the 5 security domains that we've actually factored into, keeping them common to the system and making sure that nothing actually that they're doing is hard-coded into the platform. Next slide, just to quickly go them one by one in a very short space of time. So starting with the audit part here, the philosophy here is we will actually be auditing anything by exception. So auditing everything might not be useful. And that's where the business process work streams comes in to advise us, per each, BC, what needs to be audited. And each, BC will have the capability to send, those audit either as RPC call or as push events into the auditing BC, and those audits will actually be signed first, and actually once signed will actually be created as an entry into the audit with a signed header and a message that actually will be stored. And part of that will actually be assuring persistency of all the audit entries that we have into the audit bounded context. But later on, that could actually be shared or be archived down to downstream systems, such as the Elastic stores, if we need to send some of those to be further analyzed by other systems. That is actually make sure that whatever we have is kind of like immutable, and when we share it, we'll also ensure that we share it on a least privileged model with only the BCs that will have associated privileges to be able to consume those audit entries. Next slide. The next slide is actually on the logging side, and logging is actually follows the same kind of like philosophy, except that we do not want to overload, a lot of, security measures onto it, because this is more data that will actually be used for various purposes, especially for performance thresholding, to look at security events, or even to actually do, SLA monitoring or anything else that will actually assist in terms of keeping the system availability on. So with the logging, we'll actually trigger, based on specific actions as well, and we'll ensure that we'll have the audit, BC logging everything centrally across all the BCs, and I have that information to be persisted when it's needed, and to provide it, to all the rest of the ecosystem. And in this flow, we actually put in the signing part of the encryption sign is completely optional, and depending with each specific policies of the implementer, that could actually be activated to be able to provide that. The next slide. Okay, in terms of the authentication that I've already mentioned here, we will actually ensure that across the board, authentication is done, in a similar fashion, and is also kind of like, distributed across, various systems that, the users will want to put it on. And This will actually affect, both systems and users alike, except that the parameters of the authentication information will differ. So, in system to system, there will be additional things such as tokens and claims that will actually be actually recorded. And for system users could be anything to do with user IDs that identifies them, and as well as the authentication data to actually identify them. And part of that into the crypto BC will actually bring in any other, systems that will actually help to, ensure that the authenticity of the information we have. We can actually introduce additional layers such as certificate management, issue them to users that are actually doing sensitive transaction to ensure that the ecosystem is actually much more protected. And in terms of the abstraction layer to external systems, we will actually build adapters specific to universal system that can actually talk to open protocols like OAuth or Connect OpenID, so that we don't have to try and rebuild everything afresh. We could just utilize what is in there and have a quick time to market and integrate into more IDM systems going forward. And lastly, on authorization. Authorization, we actually conceptualize it using a model that could allow us to scale and do it across the board in a much more simpler manner. So we'll actually have a one central BC, which is the authorization BC, which will actually serve as a representation of the global authorization data across all the other BCs. And each BC will actually define its roles and privileges and advertise that to the central store. And on startup, we'll actually make sure that each BC has also have their roles loaded. Otherwise, it'll actually institute a failure. Then so that we can know other systems within the landscape, we will know which access will they need to access which resources. This actually, in a nutshell, facilitate at a cloud native level, service to service authentication within the inside of the network, and we'll also guarantee that we have a least privilege model applied across the board. And also because we're going to be basing everything on a role-based authorization model, we will be able to fulfill some of the requests that we had from the business operation work streams around market checker, and we can actually even enrich that and enhance it to actually factor in more things, like by invoking things like FIDO authentication. We could actually get to a point where in some of the checkers can be automated process as long as certain characteristics are available. But this will actually be the springing board for us to manage authorization end to end within our systems. I think that's in a nutshell how we incorporated all the different security domains BC. Back to you, Pedro.
Thanks, Godfrey. So we've tried to pack as much as possible in this presentation about the details that were missing during the last convening presentation, because we hadn't had time to complete all of those. We elected these three examples, or these three examples of bounded contexts that provide valuable functionality, with the onboarding, with the transfers and the settlements, and also the cross-cutting concerns examples to demonstrate how some of those things of high importance are built and planned and designed in the future version of the platform. So we're really happy that we're in a stage where we can actually start building this. So we have enough detail on the reference architecture and on how to do the implementation. So I'm going to quickly present you our build proposal for the next phase. So what we propose is a 3 phases approach spread over the next 2 PIs, minimizing the impact of breaking changes as we promised initially, and realizing value as often as possible. These releases are cumulative in the sense that features and maturity, so that a follow-up release will obviously include all of the functionality and all of the properties of the previous releases, plus something that we add on. So what does this mean? The alpha release is the one that we will start with, and this is the result of the first development work. We will include only happy path use cases, so it will be feature incomplete. It will include obviously a new architecture structure with the new interfaces and separation of concerns. This is really difficult to do initially. We'll focus also on making it fully testable, and we will do just enough performance tests to guarantee that we are delivering on the load and performance objectives. We'll only do the fundamental issues, and we will not, and we won't spend much time on optimizations. Basically, this part of the load test, but no optimization, is guaranteeing that the structure that we have, the design that we have, still handles scalability and performance as it should without spending much time tuning. The objective of this release is to allow developers to start developing new features to be released with the new version when the new version is ready. Or to, for example, start migrating any code or integration that happened during the time that we were busy developing this alpha release. So this is an important step. We have a fully formed build plan for this release, and with the development team fully staffed, we expect this alpha release to be ready by the end of next PI. So this is the beta release, and I know we're out of time, so I'm going to quickly go through this. This phase actually might include multiple releases, starting with a beta release and then ending up with some release candidates. The objective is to make sure that we have the rest of the functionality there. It's not just a happy path. We're also going to be spending some time making the platform resilient to typical failures and start dedicating some time to performance. And this objective is so that we can start deploying this in a non-productive environment and get feedback from deployments to catch bugs that typically we don't get in laboratory environments. And then obviously we will culminate with a production release. So this is a release where everything is ready. We caught most of the bugs. It's fully resilient, scalable. And it will include an important part, which is the migration scripts available. This is something that developers will have the ability to start working on in parallel as soon as the alpha release is ready, so that we can have upgrades and migration path with scripts available as soon as possible. So our view of the build is that this, at least the first two phases, the build should be a joint effort, and we should not spread out the different parts of phase 1 and phase 2, alpha and beta. So we propose to build the foundation with a single team of dedicated developers, with our partners all in the same team. And obviously we need to call out for resources. This initial phase, especially alpha, we need a fully committed and dedicated team. And that can be fully focused on getting this initial release ready as soon as possible so that other developers can start understanding exactly how this is going to be structured and how they can use them and how they can retrofit whatever code they have and whatever the deployment they have to this new structure. It is important to say that with a smaller but still dedicated team, we can still be successful. It will probably take longer than just one PI for the alpha and two PIs for the beta and release candidates. Unfortunately, this is a very intense effort. So with less than 4 dedicated developers, it's going to be really difficult to release something like this. So it is really important that at least the first stage, we have dedicated people that are really committed to making this work, because this is going to be really difficult. This is a developer profile. We will share this. We don't have enough time. I will share this presentation with these links that link to the working document that we have. We have a Google document that we will be releasing very soon with all of the documentation that pertains to the reference architecture. We have a Miro board and we will have the presentation. So we hope that you are as excited as we are. And hopefully very soon we can start building this new generation of the platform. And again, if you'd like to participate in this build, please feel free to reach out, because we need all the help that we can get. Thank you, everyone. And thank you especially for everyone that participated in this monumental effort to design a new framework and a new platform from the ground up. That's it. Thank you.
Thank you so much, Pedro and team. Thank you for that session. I'd encourage everybody to now drop off and join us at the top of the hour for the business operations framework. Thanks, everybody.